Physics Calculus, Topic 4, Homework Problem number 39. We have a demand function where Q is the number of copies a publisher can sell per week if it sets the price at P. We want to find the price elasticity of demand when the price is $37 per copy. We want to round our answer to two places. So, to find the elasticity, we need the negative, the opposite of the derivative of the demand function, then times price, and then divided by the original demand function. Well, the derivative of Q would be the derivative of this, which would be 2 times 396 minus P to the first power, then times 396 minus P derivative. The derivative of this will end up being -1 all over 100. So Q prime ends up being, let's see, negative, and the 2 in the 100 reduced down to 50, that's what it should be, and the numerator we have 396 minus P all to the first power. Alright, so that's our demand. Now, for elasticity, we're going to take this negative 396 minus P all over 50, change the sign so it becomes positive, and then multiply it times P and divide it by Q. Dividing this by Q actually flips Q over because Q is already a fraction. So we'll have times 100 all over 396 minus P all squared. And we get some simplification. The 100 and the 50 become 2. And what else? This cancels and this becomes 1. Alright, so what we have is E equals 2P all over 396 minus P. And now we'll put $37 in here. So we'll pull out the calculator. Okay, and 37, store that into X, and then we'll have 2X divided by the quantity 396 minus X. The X is representing P. And what we get is a price of 21 cents. Okay, that's the price elasticity. Now next, we're trying to find the price at which the publishers sell the book in order to maximize revenue. Well, to maximize revenue, we need the revenue function. The revenue function is found by taking price and multiplying it times the demand function. Our demand function is 396 minus P all squared divided by 100. Okay, so we want to take the derivative of this function right here and then set it equal to 0, and so you can solve for the price. What I'm going to do this time, I'm going to expand this using binomial expansion. Binomial expansion looks like this. We have A minus B when squared will give us A squared minus 2AB plus B squared. In this case, we have 396 minus P for the binomial expansion. So 396 squared is 1568 16. 2 times A times B is 2 times 396. So 2 times 396 is going to be -792 and P, and then plus P squared. Okay, so and then we're going to take this right here and multiply it all by P, and that's going to give us R equals 156816 P minus 792 P squared, okay, plus p to the third power, and everything's over 100. Now when we take a derivative of r, this will become 1, 5, 6, 8, 16. This will be 2 times 792. So 792 times 2, which will give me negative 1584 p, and 3 times p squared. Alright, this is our derivative of the function. And I want to set this equal to 0 and solve. Now, I can treat this as a quadratic equation where a is 3, b is negative 1584, and c is 1568, 16. Now, this function I already know will have a shape like this, because the original function here has a shape like this, where you're going to have a max at the first value and a min at the second value, and we're looking for the max. Okay, so we want to know what the first and second value is and take the first value as the max. Okay, so let's plug this into the calculator as a quadratic equation. So, take a look at my numbers again. 3 store into alpha A, and then negative 1584, we're going to store that into alpha B. And for C, 15, 6, 8, 16, we're going to store that into alpha C. Okay, and now we're going to build our quadratic equation, which is going to be P equals opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So let's open up a parenthesis, and opposite of alpha B plus, let's see, the square root of alpha B squared minus 4 alpha A alpha C, and let's come from under the root and divide all of that by open parentheses 2 alpha A close parenthesis. Okay, and our first value that we get for price is 1716. Now I'm going to redo the problem. Let's see, did I do that correctly? And I'm going to put in a minus sign for the here. Okay, and that's going to give us